Hello friends, last time we have discussed the first 5 problems of the exercise 12.2, the NCERT, class 10th. In this video we will discuss the next 3 problems of the NCERT, exercise 12.2. The problem 6 says that the chord of a circle of radius 15 cm subtend an angle 60 degree at the center. Find the area of corresponding minor and major segment of the circle. Now the thing is, important here is, we should know what is the minor segment and major segment. We have discussed in the previous video also about this. It says that a chord of a circle radius 15 cm. Let's draw a circle. Let this be radius 15 cm. Subtends the angle 60 degree at the center. Let's say this is 60 degree, and let's say this is the chord. Now, if this is a 60 degree angle and this is 15, this part is called the minor segment, and remaining part except this part is called the major segment. Right? This is 60 degree. This is the radius 15. This is center of circle. Therefore, this is the radius also. Therefore, this is also 15. Now, these two are the 15, 15. Therefore, we know that this angle and this angle has to be equal, right? Because it's an isosceles triangle. Because this is 15, this is 15. Therefore, this two angle has to be same. Now, this two angle has to be same, and this is 60 degree. We know that the sum of the angles of a triangle is 180 degree. Let's say 180 degree equal to 60 degree. Let's say this is be x, and let's say this is be x. When we calculate this x, 180 minus 60 equal to 2x, and when we calculate the x, x comes out to be 60 degree. Hence, these two angles are 60 degree, and third angle is also 60 degree. Therefore, this triangle is equilateral triangle. Triangle is equilateral triangle. Now, this triangle is, let's say OAB is equilateral. Area of sector. Last time we have studied the area of sector is theta upon 360 into pi r square, right? Theta upon 360 into. Now here theta is 60 degree upon 360 degree into pi is given 3.14, and r square means r is 15 given into 15, right? Let's cancel out 6 with the 6, 1 by 6 into 3.14 into 15. Calculate this 15 into 15, then into 3.14 into 1 by 6 into 1 upon 6. This comes out to be 117.75 centimeter square. Important here is to mention the unit also. This is centimeter square. Now the area of the sector we have calculated. The area of sector means here is this whole area. This is the area of sector. Now we have to calculate the minor arc. Now we know the area of sector. If we calculate the area of this triangle, we can calculate the area of segment also. Now the area of the triangle is equilateral. Now for the equilateral triangle, the formula is root 3 by 4 into side square. Here the side is 15. Means root 3 by 4 into 15 square. The area of triangle comes out to be root 3 is 1.73 upon 4 into 15 into 15. When we calculate this, the area comes out to be 97.3125 centimeter square. Now we know the area of this triangle. We know the area of this triangle. We know the area of sector. Therefore, the area of minor segment is area of sector minus area of triangle. The area of sector is 117.75 minus 97.3125. This comes out to be 117.75 minus 97.3125. It's come out to 19.9375 centimeter square. Now this is the area of the segment. Area of segment means area of this part. Now it says the minor segment, the corresponding major segment is remaining part of the circle. Now remaining part of the circle is what? Therefore we can say major segment is equal to area of circle minus area of minor segment, right? Because the major segment is remaining part of the circle. The total circle is area of circle, and minor is area of the minor segment. The area of circle is pi r square minus area of the minor segment is 19.9375. Area of circle is 3.14 into 15 into 15 minus 19.9375. Now this is 706.50 minus 19.937, which is come out to be 686.562 centimeter square. Now this is the area of the major segment. That means remaining part, which is this part. Now we have divided circle in two parts, major segment and minor segment. Now we know the area of this minor segment as well as major segment. If we add this, we get the area of the circle also. Now let's come to the next problem. Question number 7. Question number 7. A chord of a circle radius 12 cm subtend angle 120 degree at center. Find the area of the corresponding segment of the circle. Now this problem is same. Let's draw the diagram here. Let's be circle. The radius is given 12. Let's say this is radius. And chord subtend angle 120 degree at center. Let's draw the 120 degree and this chord. The angle given is 120 degree. Now this is 120 degree. This is 12. Obviously this is the radius because this is center of circle and this is the on the circle and this is on the circle, this is center of circle, therefore this is also a radius, therefore the radius here is 12 and 12. And now we know that again this is an isosceles triangle because the two sides are equal. Now if it is isosceles triangle, let's say this with x with the x. Total sum of the triangle is, angle of sum is 180 degree, we know that, equal to say x plus 120 degree. Now this is 60 degree equal to 2x and x equal to 30 degree. Now this is 30 degree now. This is 30 degree now. This is 120 degree, right? Now if you want to calculate the area of this segment, corresponding segment, we should know the area of the triangle here also. Now the area of triangle, this is 30, this is the 30, this is 120. Let's draw a straight line from here perpendicular to this chord, right? Now this is 90 degree. Now this is 30 degree. This is 60 degree, right? This is 120 degree. Because we know that the perpendicular drawn from the chord to the center of circle is bisect this angle. Therefore, this is 120. Therefore, remaining part is 60 degree. Here also, remaining part is 60 degree. This is 30 degree, which is given, and this is 90. Now it's a right angle triangle. Now we have two right angle triangle here. We have two right angle triangle here. This is one of the triangle. This is another triangle. We have two different triangles now. Now we have to calculate the area of these triangles. The area of the right angle triangle is what? Half base into height. We don't know this perpendicular distance. Even we don't know this distance also. We know only the distance, which is hypotenuse. Right? Let's extend this diagram here. This is 12. This is 90 degree. This is 60 degree. This is 30 degree. We know this 12 and we have to calculate the area. Now we have studied the trigonometry earlier. This is 12, this is 30. Sine 30 is half, which is perpendicular upon hypotenuse. Perpendicular is unknown. Hypotenuse we know that is 12, right? Therefore P is equal to 6. We know that this is 6 now, right? Now calculate the base similar way. Cos 30 is root 3 by 2, which is equal to base upon hypotenuse. We don't know the base, we know the hypotenuse, b upon 12. B is equals to 6 root 3, right? Now this area of this triangle is half base is what? 6 root 3 into height is 6, that is 18 root 3. Now this is the area of this triangle. This triangle and this triangle are similar, exactly similar. Therefore these two triangles have the same area. Therefore total area of the triangle is twice of 18 root 3, which is 36. Now we know the area of triangle now. The complete area of triangle is 36 root 3. Complete area of triangle is 36 root 3. The area of sector is, we can easily calculate, area of sector is 120. Area of sector is what? Theta upon 360 into pi r square. Theta here is 120 upon 360 into pi is 3.14 into r is what? 15 into 15, which is equal to 150.72. We know the area of sector here, right? We know the area of sector now, which is 150.72 centimeter square. The area of segment here is, therefore area of segment is equal to area of sector minus area of triangle. Area of segment is 150.72 minus area of triangle is 36 root 3. 36 root 3 is 62.28, which is equal to, this is equal to 88 point. The area of the segment is this. It means that we have followed the process. We have calculated this area of this triangle, then we have calculated the area of the sector, and then we subtracted them to get the area of this segment. Right? Now next question. Next is, a horse is tied to a peg at the corner of a square shaped grass field of side 15 meter by means of 5 meter long rope. The area of that part in the field in which the horse can graze. Now this is the horse, this is the rope. Now this rope is 5 meter. Right? Now it says the area of the part in which horse can graze. Now obviously the maximum distance a horse can be when this rope is straightened. Now obviously when this rod is straightened, here this is, and when the horse is here and the horse is here, and when we look at the situation, it will graze into the circular form. Right? This is the maximum this thing can be happen over here. It should be a circular fashion, because the maximum distance from this point would be 5, and the maximum distance from certain point is 5, makes a circular figure. And now this is a square thing, therefore this angle is 90 degree. Now this is what called the area of the sector. The area of the sector. The area of sector, we have theta, which is 90 degree upon 360 into pi is 3.14 into r square is what, 5 into 5. Now when we calculate this area, it's come out to be 19.625. The area of the sector he grazes is 19.625. Now this is done. The increase in the grazing area if the rope were 10 meter long instead of 5 meter. Now if the rope length is increased to the 10 meter, right, and the field size is 15 meter, so it can graze into this field. Right? Now again the area of sector is 90 upon 360 into pi into r square is what, 10 into 10. Now let's calculate this. 1 by 4, 3.14 into 10 to 10, it's come out to be 78.5 centimeter square, or sorry, meter square. This is meter square. Now the increase in the area is total area of the bigger sector minus area of the smaller sector. The increase in the area is this. Increase in the area is increase 78.5 minus 19.625, which come out to be 58.875 meter square. This is the increase in the area of this. Now let me extend this problem and think, if the rope is, instead of 10 it's 15 and then 20. Now you have the two problems for your home, 15 meter rope and 20 meter rope. Find the answer and comment to the video about your answers. If you're not able to solve this problem, ask me, I'll give you a solution for this also, third and the fourth. Thank you.